Welcome to this video lesson. Here we are going to do some practice questions on velocity time and acceleration time graphs and the information that we can extract from those. In the first question here, we are given a graph of velocity time. So let's imagine that this is time in seconds, and we are asked to find a few set of information. The first one is the change in velocity from 1 to 3 seconds. So at time 1, so I'll put some information. No, I'll just do part A. So velocity 1 is equal to 1, and velocity 2 is equal to, or velocity at time 3 is equal to 3. And my unit is meters per second east. And to find the change in velocity, well, I just subtract one from the other. So change of velocity from 1 to 3 is velocity 3 minus velocity 1. And I'm going to take east to be positive and label that like this. And velocity 3 minus 1, that's going to give me 2.0 meters per second in the east direction. For B, changing velocity from 5 to 8. So from 5, my velocity at 5 is -3, and my velocity at 8 is also -3. So the change in velocity from 5 to 8, I'm not going to write all the information down for this one, is the velocity at 8 minus velocity at 5. In this case, velocity 8 is -3, and velocity 5 is also -3, so this is equal to 0 meters per second in the east direction. The total change in velocity for the entire trip, well, that's not bad. That's velocity at the very beginning to the velocity at the very end. So for C, that's the change in velocity from 0 to 8 seconds. And that's going to be the velocity of 8 minus velocity of 0. Or you can simply just look at, okay, velocity here was 0, velocity here was -3, so the change in velocity is -3. Or alternatively, you can put it into the equation. Velocity at 8 here is -3 meters per second. Velocity here is 0, and that's equal to -3 meters per second in the east direction. And then we're asked the average acceleration from 1 to 3. Okay, 1 to 3. So we can do this in two ways. Both answers will be the same. We can either use the equation for average acceleration, or we can use the idea that it's going to be rise over run. My rise here is 3 minus 1, because I'm going from 1 to 3, and my run is from also 3 minus 1. And I will get 1.0 meters per second squared, and that's in the east direction. You can also do this as the change in velocity from 1 to 3, which we have found here, that's 2, divided by the time it takes, which is also 2, and that will give you the exact same answer. Part E, average acceleration from 0 to 8 seconds. I'm going to use the other method of doing this. So instead of using rise over run, I will say that average acceleration from 0 to 8 seconds is going to equal to the change in velocity from 0 to 8 seconds divided by the time it takes from 0 to 8 seconds. Well, the change in velocity from 0 to 8, that's -3, or my rise, and the change in time from 0 to 8, well, that's just 8 seconds because that's 8 minus 0, or my run, which is 8. So both of these have two significant figures. Dividing, I should get the same number of significant figures, so I'm going to round my answer to negative 0.38, and my unit is meters per second squared east, or 0.38 meters per second squared west. Outline the motion. So there's a lot happening in here. There's a few regions that we need to consider. Let's do that. We need a little bit more space. I'm just going to zoom out here and write in this section. The thickness of my pen is going to change, but that should be okay. So we got the first region from here to here, and in this region we got 0 to 3 seconds. It starts at rest. I'm saying that because it has a 0 velocity, and then it speeds up in the east direction. And we know that because initially speed is 0 and at the end speed is 3. We can see that the acceleration isn't changing. This is a straight line, so this is constant acceleration. Is there any other information that I know? Not really. You can say that the final speed is 3 meters per second, but you don't really need to include that. And that's it. And then we got 3 to 4 seconds. Let's do that using a different color so that we can see it a little bit easier. So that's here to here. Well, what's happening here? Well, velocity is decreasing from 3 all the way to 0 again. So it's slowing down. Which way is it moving? Well, the velocity here is in the east, 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 so still moving in the east direction. And constant velocity. Sorry, constant acceleration. You can talk about whether acceleration is positive or negative. In the first one, it was positive acceleration, and this one is negative acceleration. Just because positive because of the slope, negative slope here. And this is 3 to 4 seconds. How about the next section? Let's use purple again. Switch between the two. From here to here, this is 4 to 5 seconds. And what's happening here? Well, initial speed is 0, and then the final speed is 3 in the west direction this time. So it's speeding up again. It's moving west this time. It's a constant acceleration, and the acceleration is still negative. We can see it's negative because it's moving, the slope is negative, so that means acceleration is negative, and it's constant because the value of the slope isn't changing. And that's kind of it. Nothing else for this. And finally, this region to this region, that's 5 to 8 seconds. What's happening? Velocity isn't changing, so constant velocity. It's moving in which direction? Well, the velocity is negative 3 meters per second in the east direction, or 3 meters per second in the west direction. So I'm going to say moving west. You can say moving negative east, but it's weird saying that when you're talking about description of the motion. So try to use the positive. In this case, moving west. Is it accelerating? Well, velocity isn't changing. So in this case, 0 acceleration. You and some I know that some students sometimes use negative, sorry, they use constant acceleration. And in a way, you can say that because constant value of 0 throughout the whole time. But I want 0 acceleration in terms of like if it's 0 acceleration, write 0, don't write a constant acceleration. Good. And that's kind of it in this case. So it's still moving in the west direction here, and it's got a constant velocity. Let's look at question number 2. So I'm going to zoom in. Okay, we have an acceleration time graph here, and it says the initial velocity of the object is -5 meters per second in the west direction. So that's a piece of information that I will probably need at some point. And we are asked to determine the following, assuming 2 significant figures of accuracy. We can definitely do that. Part A. Determine the acceleration at times 2, time 4, time 6, and time 8. All will have arrows because acceleration is a vector quantity. It's got a direction. And there we go. We got at 2 seconds, the acceleration is 2 meters per second squared in the east direction. At time 4, it is 0 meters per second squared in the east direction. And I'm going to write this properly, so I'm just going to erase this. And I need to report my answers in 2 significant figures. So meters per second squared east. Note that I can't write 0 meters in proper number of significant figures, so I'm just going to write 0. At 6 seconds, it is at -3, and at 8 seconds, it's also -3. So -3 meters per second squared east, or +3 in west, and this one is also 3 meters per second squared east, or +3 meters per second in the west direction. Part B, change in acceleration from 4 to 6 seconds. Okay, we can definitely do that. Change in acceleration. So the change in acceleration from 4 to 6 will be the acceleration at 6 seconds minus the acceleration at 4 seconds. Acceleration at 6 seconds, I'm going to take east to be positive. I'm going to have to show that somewhere nice and clear. That would be here. And I'm going to use this all throughout the question, so I'm going to highlight it. Acceleration 6 is -3. Acceleration 4 is 0. This is going to be -3 meters per second squared in the east direction. You can either do that or read it right off the graph. 4 seconds, acceleration is 0. At 6 seconds, it is -3. And the change is -3 meters per second squared. Change in velocity. We got a few change in velocities to do. We got one from 0 to 3 seconds, so that's this region. 3 to 4, 4 to 5, and 5 to 8. In order to do that, I am going to actually just write it out. See, change in displacement is equal to area, sorry, I should say velocity, area under acceleration time graph. Okay, let's do it. From 0 to 3, I'm going to draw that with pink. Actually, I'm going to write that applies to multiple questions. So this is change in velocity from 0 to 3 seconds is going to be the area here, which is 3 divided by 2. I just remembered that I forgot the proper number of significant figures here. And this is going to be 4.5 meters per second in the east direction. Good. And then let's do purple. 3 to 4 seconds, so delta V, 3 to 4 seconds. This is part D. This is going to be the area 3 times 1 divided by 2. Should have used some better numbers here. 3 divided by 2 is 1.5 meters per second in the east direction. They're not too bad. And then let's use a different color. Let's do red for here. We got -3 and 1. So for part E, change in velocity from 4 to 5 seconds, that's going to be 1 times -3 divided by 2. That's going to be -1.5 meters per second in the east direction. And finally, let's use dark blue. Oh, that's a big one. That's a very different area. I got -3 as my height and 3 as my base. So for F, the change in velocity from 5 to 8 is going to equal to 3 times -3. It's no longer divided by 2 because it's no longer a triangle, and that's -9. So yeah, it changes, the velocity changes a lot during this time. The total change in velocity for the entire trip, okay, we can definitely do that. I'm going to do that in purple. For part G, total change, that's the total change in velocity from beginning to the very end. That's going to be the change in velocity from 0 to 3 plus the change in velocity from 3 to 4 plus the change in velocity from 4 to 5 and the change in velocity from 5 to 8. I have all of the numbers. I'm still using my positive sign convention as I stated here. And I will get, what do I have? 4.5 east, and then plus 1.5 east minus 1.5 east minus 9. I do the math, I get 1.5 minus, these two kind of cancel out, and 4.5 minus 9.0, that's -4.5, and I guess I forgot the 0.0 here, add that in. And this is also meters per second in the east direction. Okay, I'm gonna scroll up a little bit. And finally, we want the velocities at time 3, 4, 5, and 8. And we were given the initial velocity as -5 meters per second in the west direction. Way to confuse us, Mr. S. So -5 meters west, that's not a good way to write anything. So velocity at time 0, the exact velocity, note that I'm not putting the change in velocity, is given to us as -5 meters in the west direction, or meters per second. So this is the same as 5 meters per second in the east direction. So that's the velocity right at the beginning, or time 0. Okay, let's see what's happening to the velocity then. So velocity at time 3, what is it? Well, we know that the velocity at time 0 is 5 meters per second in the east direction, and the change in velocity from 0 to 3 seconds is 4.5. So it was 5. We add 4.5 to it, and what do we get? In this case, 5 plus 4.5, we're going to get 9.5 meters per second in the east direction. And then for velocity 4, velocity at time 3 was 9.5. Between time 3 and 4, the velocity changed by 1.5, and in the east direction, the speed was added in that direction. So 9.5 plus 1.5 gives us the 11 meters per second. And then we got V5. From time 4 to 5, the velocity was decreased by 1.5 in the east direction. So this is going to equal to the velocity at time 4, which is 11 minus 1.5. And in this case, we get back to 9.5 meters per second in the east direction. Finally, V8. So velocity at 5 was 9.5 meters per second. From time 5 to 8 seconds, we lost 9 meters per second in the east direction. So it was 9.5, but our speed was reduced in the east direction by 9 meters per second, and that's going to equal to 0.5. And I'm subtracting, so I need 1 decimal place as my final answer. So that's meters per second in the east direction. So my final velocity then, after the entire trip, became 0.5. If you want a formula-based kind of solution to these, you can also do that. I'll do one of them so you can kind of see. I'll just do maybe the first one, and you can use this idea throughout if you need more of a formula to kind of do these. So the change in velocity from 0 to 3 seconds is equal to velocity 3 minus velocity 0. We know that we want to figure out what velocity 3 is, so I'm going to rearrange and I will get v0 plus the change in velocity from 0 to 3. Taking east to be positive, my velocity at 0 is 5 meters per second, plus the change in velocity from 0 to 3, that's something that I found as 4.5. And I found that. I'll just show you so that you know exactly where it comes from. I got it right here, so that's where it's coming from. And then I add them up and I get 9.5. So if you want to do things based on an equation, this is how we can do it. So this is how we kind of, that's why we added these two, is because it comes from this formula over here. But you can always just look at it and say, okay, at time 0, the speed was 5 meters per second. From 0 to 3, it changed by this much, so I can just add the two numbers to get the new one.